morning. I'm assuming the audience is there. We can't see you. Welcome to the hydrogen panel this morning. We got three investors on the panel who will introduce themselves in a moment. But I just wanted to introduce myself. I'm the moderator of this panel and also set the scene on hydrogen. I'm a partner in SAS Ventures. We are one of the most successful European funding consultancies. We only work on a no-win, no-fee basis, and we work with all the key European innovation funding instruments, namely Horizon 2020, Horizon Europe, and the Innovation Fund, which we distribute the profits of the ETS trading scheme. We have raised over 300 million for our customers in the last 7 years, and a couple of notable successes in the hydrogen economy were Hydrogenius, a German company for whom we raised 2.5 million to build a pilot unit for their technology that is a carrier liquid for hydrogen that makes it very easy to carry hydrogen in the current infrastructure. We also work with Alcogen, an Estonian SOFC fuel cell company that has the most efficient fuel cells. And recently we raised 17.5 million for Electrokea, a power to methane company based in Munich, for them to build a pilot unit for their technology. So they're now working on Green Deal consortia for the January deadline, and we've got a few very interesting projects. If you want to talk about that, please get in touch. On hydrogen, it looks like finally we are on the cusp of the hydrogen economy. The EU Green Deal targets a 55% reduction of emissions relative to 1990 baseline by 2030 and a complete elimination by 2050. The jewel piece of the European Green Deal is to build a massive production and distribution capabilities for green hydrogen. Hydrogen that is electrolyzed from water using renewable energy. Specifically, the plan is to increase electrolyzer capacity in the EU from 60 megawatts to 6 gigawatts by 2024, which is in 4 years, and 40 gigawatts by 2030. That will cost between 24 and 42 billion euros. Keeping these electrolyzers fed with renewable energy will require the spending of around 300 billion euros in 80 to 120 gigawatt of new solar and wind generation capabilities. So by 2050, hydrogen is supposed to make up a massive 15% share of the EU primary energy mix, from virtually zero today. And then other parts to spend on is building a 23,000 kilometer dedicated network across Europe. That alone would cost 40 billion. So there are many investment costs that are necessary to make this happen. So whether this vision can actually pan out will much depend on cost reduction targets, whether they're realistic. The prediction is that costs can be driven down from 2.5 to 5.5 euros per kilo today, round about there, to perhaps 1.1 to 2.4 euros per kilo by 2030. But many factors have to come into play to make this a viable scenario. Clearly, investors, the public hand is very active on this. Corporates are, and investors are key to making this happen. And we want to hear today more about what the investor perspective is and where the opportunities are. So I'd like to ask you, panelists, to introduce yourself, maybe starting with Laurent. If you just say just to yourself and which investment vehicle you're working for and what your investment focus is, and just 2 or 3 minutes each, that would be great.
Okay. So I'm Laurent Baraton. I am key expert for ENGIE. And in fact, I am also a senior research engineer at ENGIE Lab Crigen, which is the R&D center of ENGIE based in north of Paris suburbs. So regarding hydrogen and the work we can have with it's as you said, it's an emerging market, and the need of breakthrough technology is really pregnant, because the efficiency of the total supply chain of hydrogen today is not at the industrial level that it should be in order to deploy as fast as it is expected to do. So at ENGIE, when we are working with startups and when we are envisioning, in fact, investment, it's rather a clear process. We first look at the technical validity of the innovation, working in collaboration with startups, and then we set up a business plan in order to find business units interested in the technologies, and then we can have considering an investment through our internal venture capital, which is called the ENGIE New Venture. But we also work with startups using H2020 collaborative project, which is a good start for to work with startups and understand the technology and validate the technology. So that's pretty much everything.
Okay, thank you very much. Claas, perhaps next.
Yeah, hello, I'm Claas from Airbus Ventures. Airbus Ventures is the corporate-sponsored venture fund with Airbus as main investor, but also with other investors globally. We have some $300 million capital commitments under management, and we are looking at possible disruptions in the whole aerospace system. Let's say from ground mobility to deep space, everything that can impact the aerospace industry. And of course, a decarbonized economy, we look at that very widely, can and will impact that our industry massively. We need to look at commitments that the industry has been giving through the ICAO, reducing CO2 emissions by 50% from 2005 levels to 2050. That's a massive change, and that will not go without hydrogen. Our mother company Airbus has announced a few interesting initiatives in that sense. We have been looking as venture fund into that as well. We started a couple of years ago, still a little bit more with the focus on electrification, fitting into the theme of urban air mobility, but we are looking at it now at a wider angle, and we are currently researching a lot in that area to find out the whole value chain and also where are spillover effects from other industries and what are, let's say, the key figures of merit that need to be changed in order to make hydrogen really viable for the aerospace industry. Parts of the industry have been working with hydrogen, in particular in space. If you see space shuttles or the big Ariane rockets, they are, of course, propelled by hydrogen already. So there is a certain technical expertise. But with hydrogen, the devil is really in the detail. It looks very easy on paper very often, but some of the technical and physical constraints are really hard nuts to crack. And we are looking at startups that can make a real difference here. And
history. So since 20 years, we have been investing globally in emerging technologies in multiple industries, including energy, water, materials, industrial IoT, and whatnot. One of our core products is an 130 million euro direct investment fund that looks at leading industrial B2B businesses. This fund is backed by 25 multinational corporates from all over the world. We are a team of 25 today with 3 offices, one in Toronto, Singapore, and in Zurich. So we cover also the globe from the team members actually deployed in the field. I'm Philipp Hasler with Emerald Technology Ventures. I'm one of the 10 sector experts within the Emerald team. I joined the company 19 years ago Prior to my career at Emerald, I have been working in electrochemistry, most notably in fuel cell. And not a surprise, today I also cover energy storage in our team, which includes largely, of course, also batteries and fuel cells and hydrogen. And I'm very happy to be here. And before we dive into the topics, I would say as we have been backed by large multinationals, we are a strong believer in cooperations. This is the way to go for companies, and I'm very happy to be here.
Excellent. Thank you, Philipp. Good to hear. I was particularly, Claas mentioned it most clearly, that hydrogen becomes an essential part of the economy. Clearly, it needs to be viable. Where do you think will hydrogen have a business case first? Because it's still far away from there being a business case in, I think, virtually all sectors. Maybe Claas, you feel like you have a view on that, but I'm interested in Philipp because he is looking at it from a sort of classic VC standpoint, and it would be good to see the contrast between corporate and VC.
Okay, do you want me to start?
Laurent,
okay. So, with hydrogen, the market is already, and it's already largely deployed for mass application in petrochemistry, or mainly in petrochemistry and chemical processes. So the question is not about hydrogen. The question is about green hydrogen.
That's right.
And how do you shift the production of this chemical at the level that we use it today, from millions of tons of hydrogen per year, from processes that is emitting 10 tons of CO2 for 1 ton of hydrogen, to a green hydrogen supply throughout Europe. I'm feeling that this business cases that already exist are not simple to address, because as you say it, we don't have electrolyzer.
You could actually explain a little bit more.
Supply chain to green hydrogen to that. So that's one thing. It's in fact already existing hydrogen industry. That's the first case. The second one is new usage, emerging technologies. Yes, my net really poor. Okay. Maybe if I shut down the video, you won't see me, but you will be able to hear me.
Maybe go closer to your. I think you use a Bluetooth headset, so you go closer to your device.
Yes, I've shut down my video. So maybe you will hear me better. Is that working?
Yeah.
Yes.
It works better, actually.
Yes. Okay.
So where would you see the first of the viable business case in the green hydrogen economy?
Yeah. So my feeling is that green hydrogen will start with new business cases like mobility, or local storage of energy, decentralized storage and decentralized production, because the other businesses, the industry businesses, are too big for the green hydrogen infrastructure that does not exist yet.
Mm-hmm.
That's
Claas, how do you see that?
Well, probably aviation will not be the first industry, but the industry needs to start now. I mean, some of you might have seen out of interest the presentation on Zero E by the Airbus research and engineering community recently, announcing a first passenger aircraft flying with hydrogen in 2035. But that means that technological choices have to be done until 2025, because you need to consider a 10-year lead time for the development of an aircraft. A few components have obviously been already decided, but it will be only a collective effort. It cannot work if the aviation industry tries to do that alone. We need to go together with other industries. We need to crack some of the hard problems that are around storage and transport of hydrogen to the end customer. And also, what does it mean for the design of an aircraft? I'm not an aircraft expert in that sense. Other people from engineering or research are much better positioned to talk about that here. But let's say the low volume density of hydrogen puts huge issues, of course, on how an aircraft has to be designed in order to be efficient and to be, let's say, competitive in its fuel consumption and the cost of fuel consumption to today's solutions. And the fuel consumption is one of the driving factors of an aircraft today, and much higher than the financing cost. So every cent that you can save on fuel cost will have clearly an impact.
No, what you're also saying is really that yes, the hydrogen aircraft is still far away, but actually the technology choices have to be made in the next few years, very, very soon, to make it happen. So it's quite real.
And it's a price question at the end of the day. So the price per kilogram needs to be in the range of $2 to $3 in order to make it happen. And direct hydrogen consumption will be probably more a solution for, let's say, not the long haul flights, but more short to medium haul. Since for long term, the volume of hydrogen needed would be simply too large. So then it's also about the conversion of green hydrogen into some synthetic fuel, perhaps with, or hopefully with, from air to capture of CO2 in order to make a real CO2 neutral synthetic fuel. That will be probably the solution for long haul flights.
No, thank you, Claas. Yeah. And Philipp, I mean, you are seeing investment proposals, I would imagine, that are also related to hydrogen. So what do you see coming on your desk, and what interests you? Where do you think there's a viable case?
Yeah, I mean, we see, of course, mostly smaller companies that develop new emerging technologies that bridge a gap to existing technologies that we see today. So in principle, I mean, clearly on the electrolysis part, this is a major area where we see deal flow both in alkaline and membrane-based electrolyzers. And in both cases, there is significant room of improvement. But I'm, of course, also cognizant that the small companies will not be able to resolve the world's problem. I think at the end, the underlying issue is that we do find an economic pathway to produce hydrogen, on one hand. But I think what longer term will be the most compelling driver for hydrogen in total is a route to store electricity, renewable electricity, in a form where we can store the product, i.e. hydrogen, liquid fuel, ammonia, whatever, over a long time. This is something that batteries cannot do. We cannot store electricity directly over a long time. We can store for hours, but we can't store for weeks, months, or even seasons. And I think this is kind of the area where I see still a lot of open questions, and the route to get there, Laurent said it initially, but also you, Claas, the route is to find the use cases today where the economics actually do make sense. And I think this is one of the problems or challenges that we, of course, see.
And I think you're picking on important challenges. Clearly, the electrolyzer challenge has to come first, because without the electrolyzer, we don't have green hydrogen. And there's 60 megawatt total capacity in Europe today, which is almost nothing. And it's quite, apart from the alkaline technology, it's quite hard to see how the other technologies, electrolyte technologies, can scale quickly. I mean, can they actually be delivered, even from the large corporates? So what do you see? Which technology will we be using for electrolyzers in the next 5-10 years? Which one can make fast enough progress and get market acceptance?
Well, if I just look at what is available today, it's clearly the alkaline electrolyzer. And the efficiency is fairly good, doesn't require any precious metals. you can get them at a reasonable price. And I think this will be the prevailing technology for the next 5-10 years. That doesn't mean that the PEM or modifications of the alkaline electrolyzers will not get into the market, but I don't see a shortage of electrolyzer capacity out there. I mean, there are rumors out there that some of the Chinese players come to the market with almost unlimited capacities that will easily meet the demand that we may have in Europe or North America. I don't think it's a technical issue, but of course, over the next 5-10 years, there have to be some technical advancements in what we have. The alkaline electrolyzer do have some deficiencies, and that, of course, you can improve, but not resolve.
So is there a danger that we are selling out to the Chinese when it comes to electrolyzers, because they're much more advanced in capacity they can deliver?
Well, we have some very potent players here in Europe and North America too. I think it's the market that will decide who's winning. I mean, I have to say that there is some very decent technology coming out of Asia, China in particular, that we can clearly value. But I'm not saying that they will win eventually, because there are others out there that are equally strong and equally capable.
Mm. Laurent, how do you see that on the electrolyzer side? Which electrolyzer technology do you think ENGIE will be using? And how do you see that picture emerging?
If you want to make business with hydrogen today at an industrial scale, you have no other choice than alkaline. You can for small application, you can start to find some PEM electrolyzers, okay, but for large scale application, alkaline is the only viable solution today. I agree on that. High temperature electrolyzers is very promising, especially in terms of efficiency, and also due to the fact that you can have what we were talking about a little bit earlier, the synthesis of fuel, e-fuel, much more easier using high temperature electrolyzers.
When you say high temperature electrolyzers, you mean SOFCs?
Yes.
Sulfur oxide fuel cells, essentially, which have many advantages. Also, they can be reversed. That's a big advantage. You see that coming?
Yes. The thing is that reversibility can be an asset, but it's not mandatory to have a functionality. I mean, if you have one tool who does one thing in an efficient way, it's a good idea technically, and so the reversibility also is in a SOFC system has one drawback, is that you don't have the same power in both sides. You don't scale the same way. If you always have so it's one functionality for one tool is a good approach in my opinion. So to go back on electrolyzers, if you want to make business with hydrogen today, you go for alkaline or PEM if the size of your application is not too high. SOEC is still in its infancy. There are some stakeholders that are moving very fast on that, but I don't see it out of a pilot phase in the next few years. So it's a timeline.
Because if we want to scale electrolyzer capacity to that levels, what was it? 40 gigawatt by 2030. Or 6 gigawatt even by 2024. It has to be 90, probably almost entirely alkaline fuel cells. Alkaline
24 years.
Right. There are not that many suppliers of that.
No.
So then the other question is, I mean, will that hydrogen for mobility? Will that be hydrogen or will it be e-fuels? I mean, the conversion from power into fuels via electrolyzer is gaining some traction. Or how far will hydrogen be used directly in transportation? And particularly in transportation, I think it's probably the biggest sector, even though there are, of course, application in industry too. Maybe Laurent, and then we move to the other.
I'm guessing here that for mobility, for heavy duty mobility or car mobility, there is some room for hydrogen because you will need zero emission vehicles able to have zero emission on long distances with good autonomy. So you have two approach. You have the electric battery, the battery vehicle, or the hydrogen vehicle, and you can have zero emission with hydrogen in cities or on the road. If you go for fuels for mobility, the only sectors where synthetic fuels have a good reason to be is for planes, because they have the high volumic density of energy. But for road or train mobility, hydrogen is the way to go. Yes, because you limit the diffuse emission of
the direct hydrogen powered.
Yeah.
I think for road and train. And maybe Claas, on a different aspect of that same story, clearly hydrogen. One needs to make sure it's safe. So from that perspective, e-fuels may be a big advantage with methanol, ammonia are much easier to handle. How do you see that from an airline perspective? How far is safety a concern for you? I mean, it is, of course, but
today there are of course high pressure tanks where you can have liquid hydrogen in. There are of course issues when the tank becomes empty and you need to refuel it. There is a moment that is a bit critical, but that can be solved. Many people have of course let's say the Challenger catastrophe in mind, where hydrogen was blowing up big time. But imagine you had another fuel and you were burning through the fuel tank. You would have also any kind of explosion here that would have not been avoided there. It is safe, but the issue is really how to get it into the tank, how to keep it compressed, and what to do if your tank is empty. You need to think of the turnaround times of aircraft at an airport. That is a key problem that needs to be solved to make the application really viable here.
Yeah, and which leads us also to the point of infrastructure. I mean, to use hydrogen directly, much more infrastructure investment has to take place than if you use e-fuels. And that's a big investment. Is that a problem, or is it an opportunity, maybe Philipp, an opportunity for VCs also to invest in technology, in companies that develop tools and fueling technologies, distribution, transport?
Yeah, I mean, well, the infrastructure challenge has been discussed heavily and is definitely an issue, but it's also an opportunity. And if you look back a little bit in history, the biggest success for fuel cells to date is in warehouse forklifts. So why is this the case? You can refuel in minutes. You have very few infrastructure requirements. You can serve a large fleet of vehicles. So this makes it actually economically, and you have a confined environment where you not want to have noxious or environmentally harmful emissions. So this is a perfect use case, and this story will continue. And I think what the industry will need is other of such success factors. And we as investors, we are not designed to invest in infrastructure. We would invest in businesses, in business propositions that actually address this and can valorize where are the sweet spot applications for, say, hydrogen today. Is it in long haul transportation for trucks? Is it in marine, or is it somewhere in industry, or is it somewhere where you can store it, convert it into liquid fuel?
So where would you say? Well, how would you answer that question? Is there another forklift opportunity?
I think I would definitely, well, what is the most hot area today is long-haul trucking. I don't yet see the economic business case, but there is huge investments being done there. It's from an infrastructure perspective, it makes a lot of sense. From an economics perspective, for the hydrogen cost, it also makes sense because you will have relatively large scale operations. So this all makes sense. Is it then economically comparable or viable compared to diesel trucks? I don't know that, and I don't think that we as investors can change that game. We can just participate to see if it's economically viable, that we say, yes, this is an area that we want to be invested in.
It surprises me a little bit because long-haul trucking is an industry that has very low margins, where operators are a lot under pressure. So where are the investments going to come from? And that's
well, there's a business case actually here in Switzerland where Hyundai actually has huge ambitions to deploy that infrastructure. And I mean, I would guess in other countries in Europe, in France, in Germany, there is this discussion ongoing. And I think if we are serious about carbon reduction or decarbonizing industry, it will possibly start at the project infrastructure level, and maybe transportation is one of the first that will adopt. I don't think it will not be marine for safety and logistics problem. It will possibly also not be the aerospace industry. It will be something that you can deploy on a project by project basis, and for that, trucking infrastructure is actually not a bad case.
So let's say if trucking became a reality, Claas, would there be technologies that also the aviation industry could be using, or you could contribute with investments there and expertise to get things off the ground?
With the industry, definitely with expertise. As a venture fund with investments, needs to be disruptive. I mean, a part of getting the prices down will come simply from the volume effects by scaling these kind of business cases. But you need another part in terms of price disruption from the energy cost that you put in, from some technological elements that you have in electrolyzers or the transport stack, etc. So that can be very interesting for sure.
Mm-hmm. And Laurent, I know you are looking at distribution of hydrogen. Is this focused on transportation too, and you're looking at trucks, or do you see also from a utility perspective opportunities in running CHP in the home, for example? Is there a possibility to run that via hydrogen?
Yes. Sorry, could you repeat your question? Because in fact, that was very tricky.
Yeah,
didn't get all the
device. Yeah, I mean, I was asking you about distribution opportunities. I know ENGIE is looking at that and see very much that as an opportunity for ENGIE as a utility. And I was wondering whether it's mainly transportation or also there could be opportunities in CHP for homes and apartment blocks, for example. Yeah, I was wondering about that.
So yes, your question comes with the in fact the ability to transport hydrogen into a gas network.
Possibly also.
So we have to approach
mixing it into gas is one opportunity.
Yeah,
is that feasible, you think?
It's feasible, technically feasible. Yes, it is. We for example, we had a project in Decher called Grid, who was studying injection of hydrogen into a local loop of distribution and mix it with natural gas. So this is feasible, and there are a lot of studies to try to understand if you can also use transportation networks and distribution networks to store and deliver hydrogen or mix of natural gas and hydrogen. So yes, distributing hydrogen is an opportunity, but for the moment, what you can do to kickstart hydrogen economy is to address new business cases and new and in fact decentralized production of hydrogen using electrolyzers and in that case, yes, mobility is a good start.
How do you think about that distributed generation of hydrogen? Yeah. I think most people think of green hydrogen production as being associated to large wind parks, probably in coastal areas, and then the fuel is transported inland. So how do you look at that distributed hydrogen production landscape?
Yes, also long distance hydrogen transportation is a technical bottleneck. for hydrogen economy. And you know Hydrogenius, and there are other startups like, for example, in France, IC Lab, who are working on innovative way to store hydrogen on molecules. It's not the same. It's not the same approach than synthetic fuels, because the idea is to vectorize hydrogen on a molecule, so you can recycle and then transport hydrogen back and forth. The main advantage of this approach is that you have access to very low-cost renewable electricity and large scale in areas where you have abundant sun or wind, and then you have a low-cost electricity. Because one thing that is very important to know is that more than half of the final cost of hydrogen, when you consider electrolysis and green electrolysis, is electricity.
Yeah.
And you don't have green hydrogen using electrolysis if you don't have green electricity.
Yeah.
So you need this electricity.
And that is also very important. I'm wondering, is this a consideration of emeralds? Are there other ways that VCs can help make an investment that bring wind power costs down and solar costs down, or is it that has escaped now? It's purely industrially driven.
No, I think both wind and solar has gotten to a maturity stage where VCs have no more role to play. So it's really a pure volume and scale and reliability issue. And I mean, if you look at recent announcements in renewable electricity, you can see today at utility scale 1 to 2 cents production costs for solar and wind in certain geographies, which makes it actually very attractive for large-scale hydrogen production. I don't think that this is an area where a VC would typically play in. This is more infrastructure. This is private equity type of investments, but not for a VC. We are too small for that.
You see that happen? Did you see that prices are coming down enough to help the green hydrogen economy off the ground?
Well, look at the Aqua project that has been announced a couple of months ago in KSA. I mean, this is a leapfrog project in the renewable hydrogen space. It's unbeatable and it's large scale. So this, I think, is the future. We will see more of those, I'm pretty sure. And this will actually enable or reduce some of the perceived risks of many players in the industry, that this is just another pipe dream that people had 20, 40, or 60 years ago.
Yeah. Yeah, and we're now coming to a point where we would invite questions from the audience. It would be nice to hear what your thoughts are, and perhaps our illustrious panel can address some of the challenges you see. So please come up with those questions.
Maybe one additional point here in terms of energy prices. What I see in the VC space recently, and that surprised me at the very beginning when I looked at that, is that there's more and more money flowing into fusion, actually, nuclear fusion as an energy source, which could also be perceived somehow green. And if it would come to work on a large scale, it would of course change a lot the energy problems of the world here. And what we see is then that, let's say, end to end, you could bring down a hydrogen price through electrolyzers fueled by fusion at the beginning down to the $2-3 per kilogram that the industry is really looking for. It's highly speculative, but we see actually quite some money flow into that. And that is something, when you see money flow, that you cannot ignore as a VC, of course.
How do you see the time frame? You're feeling fusion could be realistic as a serious source of energy. What time frames do you see?
It's probably not. It depends on the different technologies. It's highly experimental, but we are of course not talking next 5 years. That's clear. I mean, it is decoupled from, let's say, the target we have for the aviation industry here, but it could be a long-term solution to make, let's say, the final breakthrough on energy price.
Right. That's a good point. And look,
that's very yes, that's very interesting. It's a very interesting approach, and for regarding it's clearly a long shot. But what is very also funny somewhere is that you will need hydrogen to power the fusion, because what you fuse in a fusion reactor is hydrogen.
Right.
But I think the relative output of the power is, of course, then much higher in a way.
Okay, here's a question from the audience, and it's around. There's much focus on also on the startup side on generating hydrogen, and much less is a perception here on transportation and compression and refueling side for hydrogen. I mean, maybe you talk a little bit about fueling, refueling, fueling technologies. They are clearly critical for fast fueling and safe fueling, and making it viable for the infrastructure to develop. Do you see opportunities on your desk? Is there something you would like to see that's not out there that you haven't seen yet? On that particular issue, or maybe on other points too, but let's look at refueling first.
Yes, we have seen opportunities that there are startups out there that would, let's say, deliver the hydrogen directly in a pressurized tank, and then you can use it directly. And then if you need to refuel, you simply exchange the tank. It's a bit like the battery startup you might know from the past, a Better Place, in that sense.
Right. Yeah.
On passenger cars, it's probably not very practical due to some mechanical issues. But if I'm looking at aviation, I would not deem that completely unrealistic. I think that could be really a viable alternative to do it that way.
That's interesting, yeah.
Because the problem of refueling that I touched upon earlier, which is also a safety issue, can then be really decoupled from the turnaround time of the aircraft. But it requires additional infrastructure at airports.
So this is also a concept, of course, which could well be viable for road transport, particularly in trucking. Why could one not use the same principle and make it work in that sector?
Or even for maritime applications.
Or maritime. That's actually a good point. Do you see something, Philipp, on refueling?
Yeah, actually not that many, to be honest with you. So I think this is somehow also related to the maturity of the industry. I mean, the industry, the supply chain is not yet there. Where we see gaps is more on the production side. So we do know what the limitations are of, say, a fuel cell, how we can improve efficiency, how we can reduce complexity of an alkaline electrolyzer, how we can reduce the BOM in a PEM electrolyzer. We all see this. While in the downstream, in the compression part, in the automotive industry, they already have made the decision to go for compressed hydrogen. So it will be very difficult to come up with a better solution. So where you can play is, of course, in the refueling part itself. So how do you fill a tank in a truck, bus, or a car or whatever? But there's typically not that much IP involved in this. And so I think this is also an area where fewer companies will be present, because it will be more difficult for them to defend their position if they had a better solution what is out there. So while when you are in a material space, you can protect by patents a material or a process or whatnot. In the refueling compression part, what do you want to protect? It's more difficult, and I think this is one of the reasons why we actually do not see that many companies, startups landing on our desk.
It's quite curious. I mean, that you are seeing a lot of proposals around electrolyzer improvements, because I would have thought at this point that the industrials are thinking about that mostly. So it's clearly a challenge for for Siemens, etc., to improve PEM, and for ThyssenKrupp to think about alkaline. And there are a number of companies out there. So I'm surprised that startups think about that, and how would they feed into the development of the corporates? Can you help them with that? Can you really place them in the right way in this industry?
Yeah, I think it's a synergistic approach. I mean, if you look at the large corporates, the Siemens and the ENGIEs and the likes, they are good in high volume manufacturing, in getting the cost down. Startups are much better in develop a new trick or resolve an issue. So they have to cooperate. But if you are a producing company that has an order book that you have to fulfill, if you have to provide guarantees and whatnot, then you are not that eager to try something out, new, novel that you didn't dare to do before. So I think this is where the startups and the corporates actually work together very well. Both need each other. One is good in one and the other is good in the other.
Yeah. That's right. Just a little interception. I'm asked to mention the companies, the ventures that asked questions. So the question on compression and refueling came from Robert Strotz at Hydrogen in Latvia, and there was an earlier question on safety that came from this company called. That has gone away there.
Inspiration was
Inspirion.
From
Inspirion in Sweden. Patrick Dahlqvist was a familiar name.
Maybe if I can add something about why startups are working on mostly on production of hydrogen electrolysis and not more downstream on the storage and compression. For the compression, I'm not so sure that's true, because there is one technology. There is a lot of technological development on gas compression. You take Linde with the ionic liquid compressor. That's one thing, very efficient to compress hydrogen. And the other thing is that people are looking into electrochemical compression of hydrogen, being able to compress hydrogen with a PEM system. You have companies like HIGHTECH or working on that type of technology. So for the compression, it's an issue that is a little bit addressed. My point was also that that's because most of the time startups comes from a patent background. Let's call it that way, that is developed in the academic world, and that is tried to be valorized from academic research. And the thing is that most of the people in the academic research work on the hydrogen production and the reaction and the process. Storage, transportation is much more material issues, and there is less R&D on that subject. So there is less innovation, because you require more intense also manufacturing stuff to address this type of technology.
Mm-hmm.
I don't know if you agree. That's my point of view on the subject.
Okay, that's a very, very important contribution. And maybe a follow-on question. What now, slightly different topic, what would you like to see from startup as you don't see, where you really say, well, we see opportunity within the ENGIE universe, and we can help those startups, we can work with them. What topics do you don't see addressed?
On the hydrogen supply chain, there is no subject where I didn't met a startup or a small company trying to address it. No, that's true. That's true. And in fact, we have a pipeline of startups that we have to deep dive. That is quite full. There is a real momentum on hydrogen, and I think that's a good signal, because yes, hydrogen economy has been around since the 70s and never succeeded into take off. And there is something in the air that says that maybe it's now. And there are economical and environmental advantage of hydrogen that make it a good tool to address current issues, to the current issues that we currently face. So now there is no part of the supply chain where there is no startup. Even, for example, in Laurent, which is in the security field and sensor development, I mean, it's mostly covered.
Okay, interesting. Claas, do you have a contribution on this topic?
Yeah. I mean, I would see also in the transport problem maybe an opportunity in converting green hydrogen into something else and then reconvert it at the usage. And technologies who would address that with let's say low efficiency losses and let's say minimal energy consumption could be a viable way to address the storage and transport problem. I've been seeing a small startup in the car industry who tries to address that. So there are ideas out. Probably there's no solution that will serve all customers and all applications. So we will have a big flower bouquet of solutions that will serve then the overall target at the end of the day.
And also you're putting a little bit of the focus again on e-fuels and whether it's hydrogen, green hydrogen itself or e-fuels in the end that will win. Maybe none will win. There will be different applications for different fuel types. But it's interesting that you mention conversion and reconversion because clearly there are energy losses. We can't get away from that. And that's with one conversion step, we're already very far away from economic viability. So I'm surprised you find interest in it. But clearly you see a route perhaps to get to viability.
Yeah, it depends, of course, on the figures of merit. I mean, that's still difficult to forecast, but there are interesting ideas out that I think are worth exploring it, definitely. And then, of course, it depends also on the form of hydrogen you need at the end of consumption. If you have a fuel cell running at the end, you need very pure hydrogen. If you want to burn it, like the proposal we have seen from Airbus on the ZEROe, then you can afford maybe a degree that is maybe not as pure as needed as for fuel cells.
Mm-hmm. Yeah, okay. If I can add another line of thought here, I actually think what I wish to see is that the startups and also the corporates, everybody is looking more at the economic use cases. So I think when we look back, I mean, we all love technologies, but the technologies do not solve the problem. So we need to find a way to capitalize on the technology, to make money out of it. And at the end, I don't care if it's an alkaline electrolyzer or a PEM electrolyzer. I don't care if it's ammonia, compressed hydrogen, or whatever liquid e-fuel. I do care, does it economically make sense? And I think also looking back at history, I mean, Plug Power is a very good example. They have become very successful, profitable, because they had a very good use case that economically made a lot of sense. So this is, I think, the way how we as an ecosystem can evidence to the community this is something economically viable.
It's absolutely important that you put that focus on it. Where do you think one should focus on the small applications, the niches, the forklifts, if you call it a niche, or so large-scale applications? For example, we're working with a project on power to methanol for the shipping industry. That has to be large-scale, otherwise it won't work. And you go via scale to reduce the costs and make it viable. Or you start small in a niche and sort of build from there, find somebody who's willing to pay for it.
I think by nature, it will start in a niche. Also, the niche cannot be too small. So, I mean, forklift is not a small niche. So they're quite a sizable niche in that sense. And it will then spill over into other industries as well. I mean, it's all clear if you talk about fuel cells. Without the automotive industry, the cost will not get down to a price point where it becomes viable for ships, for airplanes, for mass adoption. So there has to be a role for the automotive industry. But where to start? I need to demonstrate that I have a useful, economically viable case to start with.
No. Makes sense?
If I can add
something, yes. Maybe make them the next two sort of closing statements. I think Philipp already has a bit of a closing statement. Good. Laurent, your closing statement and in response to Philipp, and maybe Claas about you. Then we can.
regarding the e-fuel or synthetic fuels, there is one thing that is important to have in mind too, is that you'll need CO2. You need carbon to make the molecules, and when you're gonna look for carbon, you're gonna first look for concentrated emission of carbon, so industrial applications. So you will have a volume of carbon that you will need to turn back into a molecule that is huge, and so you will need large scale hydrogen production. So that's it. I'm feeling that large-scale hydrogen production will come in the industrial fields, where you will need it to, for example, to get greener petrochemistry. But you will first have to go through emerging application in order to reach that scale. And the emerging application is mobility and local storage of renewable as hydrogen.
Let's keep that in mind, and ENGIE is very clear about that. Claas, maybe a last word.
Yeah, I can only agree to what Philipp and Laurent have said here. I see it also starting in a niche market, at least from a venture capital perspective. A niche market is very nice to develop here something and to have the scaling in a reasonable time frame. And then spillover effects will come, and then maybe other types of investors might be better placed to run that. But I think we have all the finance industry around technology, be it VCs, be it PEs. We have a collective responsibility to work on that and maybe to make our world really better here. The targets for a green economy are not just there for economic elements, but also for the better of our children to come. But at the end of the day, yes, it needs to work economically. So we need to do it in a way.
And it's very good that you highlight that at the end too, because we are kind of excited about this. There is an opportunity to make the world run better, to really improve the energy system. But the economic challenge hasn't been, that we learned also, hasn't been solved. There are huge challenges, technical challenges ahead, and scale-up challenges, I think. And this panel highlighted that very well. And I feel it's not the plethora of opportunity from the startups that maybe other sectors show, which is quite complex. But there's certainly an interesting sector to get involved if people have IP and really can solve the serious issues. So thank you very much. We're bang on time. I hand over to thank you, panelists. Very, very interesting, very knowledgeable contributions. And I hand over to the organizers for a last organizational word.